Good morning, YouTube. So this is my old PowerFast 37005 Rivet Nut installer. There you can see the model name. I think this was made by Swingline, and this is a swivel head. You can turn it any direction. As you squeeze the handles, it pulls this rod in, and you use that to set rivet nuts or nut certs. There's several names for these. You basically screw that in there, and then this pulls it in very much like a pop rivet, except it squishes the nut cert onto things like sheet metal. So I'm using that here. So I think the last time I was using this, you had these pieces across the end here, and then there would be a mandrel that's screwed in there. You can see what's left of the threads. This thing here basically collapsed and it broke through the threads. You can see how the piece cracked there, and there's just a thin web of metal on the outside here, and then that whole thing, like I said, had collapsed. They started out together like that, forming a thread, but then they split and cracked like that. I tried to use it this time. What I did was I tried to squeeze this back roughly straight, and I tried putting a hose clamp around there to hold it from spreading out, and then it went bang the last time I tried to use it. So here's the part I ended up making, and I gave this thing a coat of hammered silver paint, and now you wouldn't even know that that didn't come like that. So there's my repair. I'll show you how I made this piece. And this thing works really well. This probably works better than it did when it was brand new. Just show you how this tool works. But there's a threaded piece in the middle there, and when you squeeze the handle, that pulls back. What's inside there is you have these pullers. Now these are reverse threaded, so they've got a left-hand thread there, and then there's this snout, or whatever you want to call it, that screws over there. Normally, it used to have two of these right here that came together here. There's threads in the middle, or into those threads, you screwed one of these mandrels. And then the mandrel has the right size hole to let this pulling rod through there. That would go on there, screw in roughly there, and then you would screw this into your threaded insert, and then when you squeeze the handle, it would pull this, which was screwed into that, and it would compress the threaded insert against this mandrel, and it would collapse the back side against the sheet metal. They had this cutout here. I don't think I've ever used that. I think the idea was you could get in here. There's some flats on these surfaces. I think the idea was if this got stuck in there and you couldn't turn it out, you can see there's the flats. You could, I guess, get a wrench in there or something, but like I say, I never used that feature, and I don't know what kind of wrench you would get in there, because the flats are basically as wide as the opening there. But because that opening was there and then the threads were there, this whole thing collapsed. You can see how thin that metal is right there. There's hardly anything to it, so no wonder it cracked. So anyway, last night I dug through my parts box, and I had this piece of 1-inch steel rod. I don't know, what is it, about 1.5 inches long. It was just a cut off piece. So I chucked this guy up in the lathe and kind of cleaned it off here so it's roughly circular, because this whole thing was distorted. It was like, I think on this dimension it was like 0.77 inches, and on this dimension it was like 0.81. So the whole piece had distorted from the pressure. So what I did was I turned it down to just over 3/4 inch, and I had a 3/4 inch drill bit. So I drilled down here with the 3/4, and then I drilled through and tapped it for that thread, which is M10 by 125, and I have it so this thing will just jam in there. I'm not ready to press this thing on, because one thing I've got to do here is I've got to shorten this thing down. You can see with this thing, it's got to be right about there to the thread, and I'm pretty close, because the idea is you need this mandrel all the way out at the end. Yeah, so there's 19.5, and then if you pull it in, it goes to 19. So this thing has about a 1/2 inch of pull when you squeeze the handle. Okay, so there's how I could chuck the that snout piece up in my lathe here, and I got it turned down. Initially, these tabs here were sort of bent outward. I think I took it over to the vise and squeezed these in so they were not sticking out so far, and then I also tried to kind of round this thing up by squeezing the wide side and then going back and forth until I got pretty consistent diameter. I finally convinced myself that I don't need this press fit, so I turned it down just a bit so I can just slide this thing on and off like that. One thing I need to do is I've got to go inside there and remove that chamfer. So flatten out the bottom of the hole so this can slide down all the way. Okay, yeah, I think that's pretty close to what I need there. I'm probably still a little bit long here because I've got to put this in. And let's see, then this is left-hand thread, so you screw that in. The mandrel goes in. And yeah, that's probably a little bit too long. See, it won't work for this size, because I have to be able to put this on, and there's got to be enough thread sticking out to catch, and right now there isn't. I got to take that out there, and then I might have to just trim some off the end, and I figure instead of trying to measure and cut it exactly to length, I'll just make it a little oversized and then whittle it down until it works. Okay, I think I got it dialed in a little better. I had to shorten the nose a little farther. So the trick is you need to thread the insert on until you just have the end of the stud there, the threaded part, right at the end of the threads, because the threads are way up here. The bottom part here, this compresses down here, and there's no threads in it. So you got to get all the way up there, and then you need a little bit of a gap there so that you can pull the handle in. And then there's one that went in just right, so I got to make sure I go in the right way. And then you get it right over there. And let's see if we can get this one on camera here. So you got to make sure it's pulled in. Yeah, let me get this up. You got to get both hands on here. Now it's not like a pop rivet where it breaks the puller thing off. You just have to squeeze it until it bottoms out, and that's where you need to adjust the thread there so that it just bottoms out when it's compressed fully there, and then you let it go, and now you can just spin it off. So there we go. I got 2 threaded inserts. Finally got this thing working like it originally did. Here's the little wrench they give you to loosen and tighten this left-hand thread. Like I say, I'm still not sure what this slot was for, because there's no way you could get a wrench in that slot. Yeah, so here's the other mandrels that came with this. Let's see, that's the biggest one there. I think that's 1/4 and then it's got a big mandrel that fits that larger rod, and then this was 1024. Yeah, I think this one was a number 8 thread, probably 832, and you can see that one, it's got a smaller hole and it only goes through part way. And then I think this one was a number 6 thread, and it's got the smallest mandrel. So yeah, here's one of the 1/4-inch nut certs, and you can see it's a fair bit longer, a couple of threads longer, so you have to be able to screw this in farther, and then I think there's more crush space in there. So this one might need to go in a little bit farther, but I'll wait until I need to use this, because it kind of depends on what you're putting the threads into, how thick the material is. That's the 1024 inserts, or they call it rivet nuts, and it goes from 0.20 up to 0.13 inches, or roughly 1/2 millimeter, up to a little over 3 millimeter, 1/8 inch thick. So depending on how thick a material, that influences how much you have to compress that. So like these have to compress a lot because there's not much material there, so you've got to crush the full length. Now if you go to 1/8 inch thick material, you don't have to crush it as far, because it starts crushing higher up and then it bottoms out at that 1/8 inch. Now this metal is like 0.40, roughly 1 millimeter. I don't know why they had that notch in there, because that really weakened this thing. And I mean, if this were carbon steel, it would be okay. I think it's aluminum. I don't know if it's hardened aluminum, or it's really weird turning. It's kind of a crappy metal. I don't know. And the rest of the tool is like pretty decent construction. You know, it's nice heavy duty. You got a lot of leverage. And then they put this cheap cast metal thing on there. Yeah, hope you enjoyed that. Stay tuned. We'll show putting these lights in next. So stay tuned for that. And as always, thanks for watching.